This is a piece of equipment that I've been wanting to get for a while, and it just came in today. This is a 4-way passive GPS RF splitter. And the way a GPS RF splitter is differentiated from a normal RF splitter is that it has DC blocks on all but one of the outputs. And the reason for that is because most GPS receivers actually push anywhere from 3 to sometimes up to as much as 12 volts up the coax for powering a low noise amplifier in the antenna. And if you use a normal RF splitter, the GPS units, if they both transmit that DC voltage into each other, they can kill each other, and you want to avoid that. There are a couple different ways to get around that. One, some GPS receivers simply don't have that capability, and so they wouldn't be damaged by this. Sometimes it can be disabled in software. Sometimes you could do board level modifications to turn it off, or you could get a plain RF splitter and just buy DC blocks for all the ports, but then that gets kind of messy. The reason it's taken me a while to get one of these is because most are fairly expensive. For example, some of the 2-port GPS splitters I was looking at were, $250 to $350. 4-port ones like this were even more expensive, like $400 or $600. And the huge advantage to this is to feed one antenna into multiple different receivers, and so you can use this device to use a single antenna to characterize multiple receivers, because they'll all be receiving the same signal. The signal, granted, will be a little bit weaker than if it were fed into a single device, but usually that's not really a big deal. And also, in my case, the cable runs are all going to be pretty short, so I'm even less concerned about it. So let's open it up, take a look. Oh, this one from Time Machines, the TM604. This was, I want to say, either $70 or $80, and a good friend of mine recommended this brand. They make a lot of really good products specifically for GPS timing related purposes. So they have antennas, RF cables, RF splitters, GNSS disciplined NTP servers, some pretty cool clocks, that kind of stuff. And there's a version of this splitter too that takes external power as well, if you wanted to, if you had receivers that didn't have power and you wanted to feed power in, this could be used as your LNA injector. So here it is. It's a very handsome little box. Something that I found pretty cute about it was the fact that the case is actually 3D printed, which doesn't really bother me at all. But there's a very nice label, and just a handful of machine screws on it. So let's pop it open. No, these are not machine screws. These are pretty coarsely threaded self-tapping screws. And before I take the lid off, so it's worth pointing out the way this thing is configured. So there's one RF input, just a standard SMA, and then 3 outputs, and they're marked as DC pass, DC block, block, block. So DC pass means it's pass through. So whatever receiver is plugged in here, its LNA amplification voltage is passed through. The other 3 are blocked. There we go. So this is pretty much what I was expecting. Just a small custom board pull out these screws. Come on. Let's try not to scratch it up too much. Let's see. Those need to be backed off a little bit. I'll just use wire strippers. So they're right at hand. Honestly, these nuts are not really necessary at all here because they're not holding it in. You sure fit it in here pretty tight. There we go. And nothing else in the case. Now let's zoom this in a little bit. So this is pretty interesting. I don't know much about RF PCB design, but so it's a very simple double-sided board, pretty thin, and looks like the blocks are just these caps, and then there's a resistor here, and then the passive device. Let's see, is that a just 0 ohm? Yep, that's just a 0 ohm. So, what's really interesting is that all these components, so there's two caps, a choke, or two chokes, and a little coil, they're all present for the DC power input. I'm surprised they just roll all the boards the same, just leaving off the connector. So if I wanted to add DC power input, presumably all I would need to do is drop that barrel connector on there and then swap out this R4 for a cap. Though it's interesting to me that they even bother. Yeah, I'm not really sure what's going on here, because I don't think that right there, that pad, is doing anything but going to the positive pin of the barrel jack, and then, you know, supporting the circuitry. I don't think the circuitry is doing anything else. Yeah, the bottom's just one big ground plane. Yeah, so that's curious. And I'd like to know more about the design of these loops. That's pretty neat. Like I said, I don't know much about RF PCB design. But I would like to know more about those loops and what exactly these resistors are doing. But because it's, you know, like this signal's coming up, going around, going up, going around, you know, but it's being split through. I don't know. I really don't know what I'm talking about, but it's a neat little device. I mean, obviously at you know, at $80 or however much, I could have made one of these for less. But one, I didn't want to risk blowing out any of my devices, and two, you know, this is a local company. It's, well, local. It's an American company, and they manufacture these in the States. So I wanted to support something local. Looks like this was manufactured either the 38th week of 2019 or the 35th week of 2019. That might be like a quality control stamp or something. Or the date of assembly, something like that. So, yeah. So next is just, let's put the lid back on it, put it all back together, and then we'll test it out. Okay, it's a little while later, and I have the splitter connected. I got 4 different receivers, including one, oh come on, focus. One Neo M8N that's essentially coupled directly in with this gender changer. But we've got an M9 in here, an M8T here, and then in this case on top of a Raspberry Pi we have another M8N. So here is UCenter running on my PC connected to the M8T, and as you can see we've got plenty of signals. We've got a ton of satellites in view, but this is a much more discerning receiver, so it's not using all of them. And then here we have a CGPS running on the Pi that has the M8N on top. And you can see we've got, you know, again, 13 satellites to use, 23 in view, with, you know, really good dilution and precision values there. And then over here, we have, this is the other M8N, the one that's just connected directly in. And it hasn't been running very long, so it's not doing great, but it's, you know, it's got a lock, it's doing a lot better, you know, than it had been a few minutes ago, that is. And then this is the M9N, and it's actually underperforming. It's not doing quite as well as I had expected. Granted, the coax I'm using for these jumpers is not very good, so I'm going to actually try the M9 again connected in this fashion. But yeah, so I just wanted to test this little device with, you know, all 4 GPS receivers connected. Oh, and then on top of that, the antenna that we're using is nothing special. It's this little U-Blox dual band. I can't see the model number, but I have a magnet on the bottom of it. So it's not really an amazing reference antenna. Soon, hopefully in the next couple weeks, I've actually got 2 of these proper timing reference antennas that I'm going to get mounted up above the roof line, and I expect that to give me much, much better performance. So, all in all, I'm very pleased with this little guy. The ability to run 4 receivers off of the same antenna is very nice, not just because it saves me from having to run a zillion antennas, but it allows me to characterize different receivers with the same signal. So, that's it for right now. Thanks for watching.